There is a type of fat in your body that your bathroom scale will never measure, your mirror will never show, and your doctor may never test for. And yet, researchers now believe it is the single most powerful driver of blood sugar dysfunction in modern adults. It does not sit beneath your skin. It wraps itself around your liver, your pancreas, and your intestines, and it operates more like a chemical factory than a storage depot. And the most unsettling part? You can look completely normal on the outside while carrying dangerous levels of it on the inside. Scientists have a name for this. They call it being TOFI, thin outside, fat inside. And studies suggest it affects a significant portion of adults who genuinely believe they are metabolically healthy. Here is the question worth staying for. What if a single food, one that most people already have in their kitchen or can find at any grocery store, has been shown in randomized, controlled, peer-reviewed clinical trials to specifically target this hidden fat and begin restoring your body's insulin response at the cellular level? Not anecdotally, not in a wellness blog, in published research using precision imaging technology that measures deep abdominal fat directly. That food is the avocado. And what the science reveals about why it works is far more interesting than anything its reputation has ever suggested. Before we get to the mechanism, it is worth understanding exactly what visceral fat is and why it behaves so differently from ordinary body fat. Most people's mental image of fat is the soft tissue underneath the skin, the kind you can press with a finger. That is subcutaneous fat. It is relatively passive. It stores energy and stays largely out of the way. Visceral fat is biologically active in a way that subcutaneous fat simply is not. It functions more like a rogue endocrine gland than a quiet energy reserve. Picture the inside of your abdominal cavity as a sealed chamber where all your vital organs operate in careful coordination. The liver processes nutrients. The pancreas monitors blood sugar and produces insulin. The intestines manage digestion and communicate with your immune system. Now imagine that chamber slowly filling with metabolically active tissue that continuously releases inflammatory molecules called adipokines directly into the portal vein, the blood vessel that drains straight into the liver. The liver receives that inflammatory signal around the clock. And one of the earliest consequences is that the liver begins to lose its sensitivity to insulin's commands. It starts ignoring the signal. This is where insulin resistance typically originates in most adults, not from a single dietary failure or a genetic sentence, but from a liver chronically overwhelmed by chemical interference originating from visceral fat. Understanding this changes the entire frame around blood sugar management. It means that for many people, addressing insulin resistance is not primarily about eating less sugar. It is about reducing the biological noise that is preventing the liver from hearing insulin in the first place. And this is exactly where the avocado's specific chemical profile becomes relevant in a way that no other commonly consumed food can quite replicate. Researchers at the University of Illinois conducted a 12-week randomized controlled trial involving adults with excess abdominal fat. One group consumed one full avocado daily. The control group followed a comparable caloric intake without avocado. At the end of 12 weeks, the researchers used DEXA imaging, a dual-energy X-ray absorptiometry scan considered the gold standard for body composition measurement, to precisely measure changes in fat distribution. The avocado group showed a measurable reduction in visceral adiposity. Not subcutaneous fat, the deep internal fat, the fat your scale cannot see. The obvious question is what is actually happening inside the body to produce that result. There are at least 4 distinct biological mechanisms at work, and each one is worth understanding because together they explain why this particular food does something that most dietary interventions simply cannot target with the same precision. The first mechanism involves a compound called oleic acid, which makes up roughly 70% of the fat content in avocado. Oleic acid is a monounsaturated fatty acid, and it has a unique relationship with a nuclear receptor inside your fat cells and liver cells called PPAR-alpha, peroxisome proliferator activated receptor alpha. Think of PPAR-alpha as the master ignition switch for fat oxidation. When it is activated, your cells shift their metabolic priority toward burning stored fat as fuel, particularly the triglycerides packed inside visceral fat deposits. Most dietary fats activate this receptor weakly or inconsistently. Oleic acid from whole avocado activates it in a consistent, measurable way. This is not theoretical. It is the same receptor targeted by certain pharmaceutical drugs designed to reduce liver fat, and the avocado achieves meaningful activation through a naturally occurring compound rather than a synthetic one. The second mechanism involves the gut, and this one has implications that go well beyond fat loss. A medium avocado contains approximately 13 to 14 grams of total fiber, with roughly 5 grams of that being soluble fiber, including beta-glucan and pectin. When soluble fiber reaches the colon, specific bacterial populations ferment it into short-chain fatty acids, particularly butyrate and propionate. These compounds travel through the same portal vein to the liver. But unlike the inflammatory adipokines released by visceral fat, they deliver anti-inflammatory signals that help resensitize liver cells to insulin. They effectively quiet the metabolic noise so the liver can begin hearing insulin's instructions again. The University of Illinois study measured gut microbiome composition alongside visceral fat data, and what they found was striking. Participants in the avocado group showed significantly higher populations of Faecalibacterium prausnitzi, one of the most potent butyrate-producing bacteria in the human gut. This was not a side effect. It was part of the mechanism. The fiber in avocado is not just filling. It is selectively feeding the bacterial population that communicates directly with the liver to reduce insulin resistance. The third mechanism is one that surprised researchers when it was first characterized. Avocados contain a rare fatty alcohol compound called avocatin B, found in virtually no other commonly consumed food. Scientists at McMaster University in Canada discovered that avocatin B inhibits a specific dysfunction in fat cell mitochondria, reducing the accumulation of toxic fat metabolites called ceramides and diacylglycerols inside liver and muscle cells. These toxic intermediates are known to interfere directly with the insulin signaling cascade at the intracellular level. When avocatin B reduces their accumulation, insulin signaling improves not at the receptor surface but deeper, inside the cell itself, where the actual metabolic work happens. This is a fundamentally different mechanism than anything dietary fiber or omega-3 fatty acids produce. It is specific, mitochondrial, and unique to this fruit. The fourth mechanism involves a carotenoid compound called lutein. Avocados are one of the most concentrated whole food sources of lutein in the human diet. Lutein operates as an inhibitor of NF-κB, nuclear factor kappa B, one of the central signaling proteins that drive systemic inflammatory cascades. When NF-κB is chronically activated, the body maintains an inflammatory environment that perpetuates both visceral fat accumulation and insulin resistance in a self-reinforcing cycle. Lutein's ability to suppress this pathway adds a layer of anti-inflammatory protection that works in parallel with the other three mechanisms. All four are operating simultaneously when you consume the whole fruit in its complete form. Now, how you consume it matters significantly, and this is where most people unknowingly undermine the entire process. The clinical evidence supporting visceral fat reduction was built on one full medium avocado per day, approximately 200 grams, not a decorative slice on toast or a few cubes in a salad. Consuming avocado as a condiment rather than a meaningful daily dose is one of the most common reasons people report no change. The full fiber load, the complete avocatin B content, and the lutein concentration all require the full fruit to reach the thresholds demonstrated in the research. The timing of when you eat it also matters. Consuming avocado alongside your largest carbohydrate-containing meal of the day significantly blunts the postprandial glucose and insulin spike that follows. The viscous soluble fiber slows gastric emptying and glucose absorption, while the fat content naturally moderates the glycemic response. Rather than adding avocado randomly to your diet, positioning it strategically with your highest carbohydrate meal gives it direct leverage over the insulin spikes that maintain resistance over time. There is also a preparation detail that most people completely overlook. The dark green flesh directly beneath the inner surface of the avocado skin contains approximately 3 times the lutein concentration of the pale interior. When most people scoop an avocado cleanly from the skin, they leave that thin dark green layer behind on the rind. Taking an extra few seconds to scrape that layer with a spoon before discarding the skin meaningfully increases the anti-inflammatory payload of every avocado you eat. It costs nothing. It just requires knowing that the layer exists. One more practical point around expectations. The timeline for this protocol is layered and requires realistic framing to stick with it. Gut microbiome composition begins shifting within 72 hours of consistent daily intake. That is the first layer, invisible but foundational. Measurable changes in fasting insulin levels typically appear around the 21-day mark in most people who follow the protocol consistently. Visible visceral fat reduction on body composition imaging appears in the clinical trials between weeks 6 and 12. Your bathroom scale in week 1 is not the right measuring tool, and using it is one of the main reasons people abandon the protocol prematurely. What is actually happening during the early days is a process called lean tissue recomposition. As liver fat begins metabolizing more efficiently and glycogen stores shift, scale weight can temporarily hold steady or even rise slightly while visceral fat volume is already decreasing. Track waist circumference at the navel. Track how stable your energy is between meals. Those are the early readouts that reflect what is actually changing. The 4 most common mistakes that cancel the benefits are worth naming clearly. Underdosing, treating avocado as a garnish rather than a therapeutic food. Measuring progress by scale weight in the first 2 to 3 weeks. Pairing avocado with sweetened ingredients, honey, flavored yogurt, sweetened smoothies, which trigger insulin spikes that partially counteract the sensitizing mechanisms you are trying to activate. And inconsistency during the critical first 2 weeks, when the gut microbiome is attempting to establish stable bacterial colonies. Occasional daily gaps during this establishment window prevent the structural colonization that produces lasting change. After those first 2 weeks, the biological foundation is in place, and occasional missed days carry far less consequence. What all of this points toward is something the medical system is often slow to communicate directly. Visceral fat accumulation and insulin resistance are not the inevitable price of aging. They are not conditions that can only be managed pharmaceutically once they appear. The biological pathways that drive them, PPAR alpha regulation, gut-liver axis signaling, mitochondrial insulin sensitivity, inflammatory cascade control, are active inside your body right now. They are not relics of a younger metabolism. They are systems waiting for specific inputs. The remarkable thing about the avocado is not that it is exotic or expensive or hard to incorporate. It is that a single food, available everywhere, contains 4 distinct compounds that target the actual biological mechanisms of metabolic dysfunction simultaneously. And the evidence is not speculative. It comes from peer-reviewed, precision-measured clinical research. Your metabolic health is not written in your birth year, and the cells doing the work inside your body right now are far more responsive to the right inputs than most people have ever been told to believe. That is not a wellness sentiment. It is what the research actually shows.